Nuclear density meters have been used by industrial processes for years to determine the density of a slurry moving through a pipeline. Although they are recognized as industry standard, operators have been under pressure to move away from nuclear density meters in recent years due to regulatory changes, increased operating and disposal costs, and the desire to modernize their instrumentation. Red meters industrial measurement systems are used in place of nuclear density meters in mining, dredging, oil and gas, and other similar applications. Red meters isn't the first non-nuclear density meter on the market. Is it another too good to be true solution that's all claims and no proof? Let's take a look. Nuclear density meters function by measuring an emitted amount of radiation from the source through the pipe and into the receiver. The difference between the radiation emitted from the source compared to the radiation accounted for at the receiver is then used to infer density. However, the path of the emitted radiation does not encompass the entire contents of the pipe, but rather a limited cross-sectional line. By not measuring the entire contents, some portion of the media will continue to pass through the process without being measured. Red meters are more accurately described as an industrial measurement system rather than solely a density meter. They take multiple direct measurements of the process media and use those measurements to calculate density. Often used as an alternative to nuclear density meters and slurries, the inline measurement instrument's technology is based around its patented flexible cartridge. The company's flagship instrument, the Red Meter Toro, also has the capacity to integrate a flow meter onto a single unit, which provides mass flow. As material flows through the pipe, the cartridge bends slightly under the weight of the media. A high-precision laser is used to detect the displacement and the deflection of the cartridge. Acting as a scale, the measurement of deflection is equated to a measurement of mass. In a fixed volume, the change in mass is divided by a stable volume. This is the most basic equation for density calculation. A variety of additional sensors measure pressure, temperature, wear, and a variety of other variables. When combining these measurements, an operator can not only truly measure their process, but also accurately and efficiently make changes downstream and automate troubleshooting. In the years since nuclear density meters were first created, major innovations have taken place in the sensor technology and computing realm. There are two types of technologies: legacy sensors and smart systems. Legacy sensors measure one variable, i.e. density or temperature, and display readings locally and/or output to a control system. Any analysis of these measurements generated by a legacy sensor must happen externally. Red meters, which are smart systems, take readings from multiple sensors integrated within the system. Then, they calculate and display measurements such as density, temperature, pressure, and the relationships between these variables. This allows the system to measure and display more sophisticated measurements, such as percent solids. Red meters are also able to provide remote access and support, as well as system updates. Any radioactive material is constantly decaying. This is gauged by the material's half-life, meaning the strength of the emissions will have over this time frame. In the industry, this is called drift. This requires regular, manual intervention for calibration and an attempt to maintain accuracy. Nuclear density meters are measuring a section of pipe, meaning material not moving directly through the gamma rays can be missed. Environmental regulations necessitate even smaller radioactive cores, meaning weak and noisy emissions that need to be damped over long periods of time to be interpreted appropriately. These readings cannot be measured in real time. They also do not use a physical calculation for density. Rather, they are inferring density based on emittance and reception of gamma radiation. Unlike density measurement methodologies, which are using energy emission, be it nuclear waves, sound waves, or ultrasonic waves, Red meter systems work by measuring the deflection of the cartridge as the materials move through it. As such, red meter's accuracy is highly dependent on the cartridge's ability to return back to the baseline, ensuring there is no drift within the readings. Red meter's engineering team developed a proprietary cartridge which ensures repeatable readings. One key advantage of the red meter is that the entire volume of media inside the pipe is measured and displayed in real time. Nuclear density meters start at an average of $10,000. The most important costs associated with a nuclear density meter is that they require monitoring, reporting, calibration, and maintenance from a trained and certified radiation safety officer. This is the most costly aspect of nuclear density meters. Removal or disposal of nuclear density meters has its own set of challenges. In some cases, disposal is more expensive than the acquisition cost of the meter. Red meters start at around $13,000. Pricing is determined by the diameter of the unit, which can be as large as 60 inches or 1,500 millimeters. There is limited upkeep and maintenance for the red meters measurement systems. They are calibrated prior to shipping and only require installation on-site. The cartridge is a consumable part with built-in wear sensors to alert when replacement is needed. Nuclear density meters require frequent, specialist, human interaction to ensure they are operating correctly and within regulations. This includes wipe or leakage tests, which must be performed to ensure no radioactive material is leaking from the device. Nuclear density meters are used by specialists, certified staff, who are familiar with their simple interfaces. Red meter systems were designed to be simple to install and use without any special training or certification. Cinder, Red meter's latest industrial software, was built using the same software you use every day, making it intuitive and easy to use. Nuclear density meters are known for their flexibility within processing applications. The clamp-on design allows them to be installed in a wide array of applications. These include most standard piping materials, as well as either horizontal or vertical pipe configurations. Available in a variety of diameters, a red meter can withstand highly abrasive slurries as well as high percent solids. Red meters can be used in mobile application, such as dredging, as well as applications that require high precision measurements. One important consideration is that red meters must be installed horizontally. Both nuclear density meters and red meters are great options for measuring the density of your process, depending on your specific needs and application. Here, our red meters, our ideal applications tend to be customers who are looking for an easy-to-use solution to measure density and mass flow, especially on large diameters. Our customers also seek us out if their applications have entrained gas or are too abrasive for ultrasonic or Coriolis meters. To find out if red meters is an appropriate solution for your application, book a demonstration via our website at redmeters.com/demo. That's redmeters.com/demo.